Okay, welcome to this new module, and it might be surprising, it's about projections. Which I think is very constitutive to an understanding of what architecture might be today, and would give you nice symmetries to the Renaissance and antique architecture and their discussions, which is a very constitutive conception in mathematics. Will help a lot. So, I like to start with this observation. I'm always a little puzzled, and that you can't see what you hear. So there are different realms, different domains. These two senses. So, and to illustrate that, I like to throw a small stone into water, and then this stone will take space. Therefore, space is circular. And this is what we can hear. Hear the waves. And the waves are around the corner, and you can go forward and back and so on, and they are in synchronicity. So therefore, this corresponds to space. You hear space, and this is of circularity. Whereas, if you are here and look at all this scenario, with your eyes, you cut space. And then you see points in time of the past. So this is -1, -2, -3. And this is time. So therefore what you see is time, and you see linearity. So therefore it's very important that time and space is not four-dimensional. Forget about that. That's very important that you're strict. It's a categorical mistake to talk about 4D. So if you look at something, see, you're always in time. Now we do a diagram. So we take the eyes of time to make a diagram. So we look at space and give that a line. This is space, and this is of any dimension, n dimension. It can be 1 dimension, 3 dimension, it can be 100 dimension, and so on. If we put time at the 4th dimension, we treat time as space, which is narrowing down the whole story to nonsense. So what we call a dimension, what we call a property, what we call a parameter is, or a parametrism is space. So it's on this axis. Time is a different domain. So, and this is orthogonal. This is time. If we put that here plus, there's minus, plus, minus, then this is the future, this is the past. Or you can say if this is the inner space, or the positive space, and this is the outer space. So this orthogonality is very important. What you can't see what you hear, and vice versa. It's a very prominent mathematical association with that. So imagine you're here. This is a circle. Again, if we start to draw, these are always the eyes of time. So then we are looking in a certain direction and we see a certain point. We go to another direction, we see another point in another point of time. So this is T1, this is T2. And this, for example, is T3. And the interesting is, these are discrete points. And so what you see is of the circle are points. And what you can do is you can connect them with lines, but this is not the circle. So, in time. The circle is a symbol. Circle is a symbol in space. Like, and you know that, with a triangle, this is rational, this is a rational number, this is an irrational number. So we always said if this, for example, here is 1, this is 1, this is square root of 2. So we symbolize the whole story because this is neither an odd nor an even number. So it's simply not a number. So it's getting a symbol. And if we are not with numbers, we are beyond calculability and we are entering space and we are using symbols. This is what writing is about. So let's go for detail and show that with code. This, for example, is we have a graphics, a circle, and we discretize it with a certain measure. This gives you a set of points, coordinates, in space. These are the points we can see. So they're discrete points. And this is the graphic. We make an infinite line, 00 to 21. It's here. We render the points as well as graphics and make that to a certain size to get this graphic. Do that. We have this graphic. So if we now go and listen to the talks, so this is the eyes of time, this is the ears of time, the circle is different. So we can't see it, we have to hear it, so we have to talk about it, or we have to write it. So we have to symbolize the circle. And the circle is, for the ears, is x squared plus y squared equals 1. That's a circle. And the line is x equals to y. We associated that with, assign that to the symbol circle, and we assign the other equation to, this is assignment, and this is equation, equality. Assignment of this equation to this symbol. So now Mathematica gives you this nice function which says solve, take this equation and look for all x and y's meeting both equations. And you see the variables are here in both. So look at the x and the y as pairs meeting both equations. And do that, that's very important, at the scale or the mediality of space of the rational numbers. So which is fractions, 2 with the proportion of 2 to 3, 1 to 2, 500 to 503, and whatever. So these are the rationals. So which is the mediality or the scale of space in the antique times. If we do that, there is no intersection. So if we go to the real numbers and solve that, the same thing, but in the scale of spatiality given by the number space of the real numbers, which includes all the square roots and so on, then we get a solution. We get 2 points, and we can make this drawing. So if we go here, for example, to square root of 2, you see what Mathematica is doing. It symbolizes that because it's not a number. If we force that into a number with a certain discretization, with a certain resolution, as we had the resolution here, for example, we can do that with put that to a float, and with 10 digits, a resolution of 10, then we get that. But we can go with a resolution of 100, and we get that. And there's no repetition, no regularity, it's just, you can go to any resolution and you never will meet this point, and therefore there's no solution here. If you go to the number space of modernity from 1500 on, we can work with it because we have a new scale of our world. Okay, now it's not like that, because we as a person, we are constitutive between seeing and hearing, between space and time. So we are circulating that. This is what we do. So it's not that they are independent. So what we are interested in now is how to come from space, the circularity of space, and what can we inherit, what can we see of the space, and what can we hear of the time? What is it? So this is our interest now, is going from here to here, which means from circularity to the linearity of time. And this is called the stereographic projection. And on the other hand, we want to go from time, or the linearity, towards the circularity. And this is called the perspective projection. So we have it in symmetry, we have it here, the perspective projection, and here the stereographic projection. So we are interested in these terms. So space, we talked about that, is about the day and bright sunlight, and we cut day here with our eyes, but it is of circularity, and we cut it with our eyes, and this is night. We call that night because we get lines of time with the within the circularity of space. So we have day, we have night. And we are interested in these two different projections. I want to go in detail there. This is what we have, for example, with an illustration by Corbusier. He said this is his most important invention. And he goes with the time. And then he says, sunrise, sunset, sunrise again. And this is a poem of the right angle. And he says, the two rhythms which regulate our destiny, a sun rises, a sun sets, a sun rises again. So this is his poem, we can find it here. Poem of the right angle, about the medium. This is milieu. What we talked about, the medium or the scale of architecture. Then he goes with this diagram. And then, for example, with the water, that's important as well. We go here with Platonic elements. This is the water, or with the quadrivium, you can look it up. The water or the music. This is the air. This here is the fire, or the astronomy. And this is the earth. So I would say this is geometry. This is arithmetics. I would say, so this is given, so they call it geometry, astronomy, arithmetic, and music. This is a quadrivium. In old universities or monasteries, how to learn. The trivium, this is on the language side, and on the mathematics side it's a quadrivium, and these are the four. I would say this is logic today, and this is algebra. But this is not established. Good. Now, go for example for the water with Corbusier, just on the perspective projection. This is what he says: the level established where stops the descent of the weights to the sea, daughter of droplets and mother of vapor, at the horizon. Horizontal defines the liquid content. So, yeah, very poetic. I think it's too much to go in depth. It's important that I think it's not too esoteric what I'm telling you. It's very constitutive, and I think it's a lack of today's discussions that we don't develop fantasies on these abstractions. Okay. Now, again, with the eye of time, just to give you more how this works and why this is powerful. Again, with the eye of time, if we look at space like this, so this, for example, is the timeline, past, future. This, for example, is what we call history. And the interesting thing is, for example, this is Vitruve, this is Alberti, and this is me. And history always says it's in time. It always says it's going step by step. This is cause, effect, and so on. So what I can do, And this is always, I'm puzzling that the historians are so strict to this scheme, because I just can read, I can bypass Alberti. I don't need them, I just read the truth, which is a no-go for historians, because you jump in time. So I would say these are the eyes of space. You simply can say, okay, it's like planets. This is Vitruvius, this is Alberti, this is me, and I can look them up. And they are with circles. So here, with the eyes of time, time is linear, and this is space. And here, space is circular, and time is linear. It's this. Yeah. This is another diagram, and I think this is more adequate. So you're not following. You follow. Here you have in space. You have the circularity. It's not that you don't have lines, but primary is a circularity, and with what historians are doing is linearity. So this is truth. And here we are struggling today with, in our today's world, which is a world about space, with computing. We're struggling with fake, because truth is, you can get any kind of constellation. So here it's about justice, for example. Again, you can say, it's very esoteric again, but why should I do that? Interesting again is, for example, again with the eyes of time, this is a wall, this is room A, room B, I'm here, there's somebody else, and I want to talk. And there's an obstacle. And you have to go around and so on, but you can't do it. The interesting thing now is what we do with technology, as we did with the rational and the real number, here, and the different realm. We can translate in a circle like this, we can translate our audio, for example, to a new domain. For example, electromagnetic realm. We transfer it. This is called a functor. And then we go with electromagnetic, which, by the way, is space and time and space. You go here in the other domain, which is able to pass the obstacle, and then you go back. F within verse, and translate it back to our, not the electromagnetic space, but to the physical space. And by that, you are able to bypass the obstacle. This is what we have with a phone call. So this is exactly a technique which is working on these schemes. And what, by the way, is a window or a door? Yeah?